Hi everybody, this is Haruna and Rashmi, and welcome to session 4 of our webinar series, Integrating 3D Modeling and Printing in Your Classroom. Today we'll go into BlocksCAD.
So again, today's agenda is we'll be talking about BlocksCAD, again, its comparison with Tinkercad and BlocksCAD. We'll also overview some of the tools of BlocksCAD, and we'll go over some tips. And then comes the fun part, which is the assignment.
And this is going to be a fairly long webinar, so you feel free to stop it in the middle and come back to it if it's getting a little too overwhelming.
So what is BlocksCAD? It's like Scratch. It has a coding platform just like Scratch for 3D modeling. It is compatible with 3D printing, so you are using blocks to design objects, which you can then 3D print.
And the nice thing about BlocksCAD is you can learn coding principles while you're using math to create three-dimensional models. So rather than just dragging in like you were doing in Tinkercad, you can say, okay, create sphere and then move, and you can try to integrate a lot more of the computational thinking piece into it.
So some of the basic steps in designing the BlocksCAD objects or geometries are, you'll have certain basic steps like a box, a cylinder, sphere, torus. Then you'll be applying some transformations such as translate, rotate, scale, or you can mirror those objects.
And then you take those different objects and combine them using different effects. So it's similar to in BlocksCAD where you had a whole and a solid, but you actually get more options in BlocksCAD.
So a quick comparison of Tinkercad versus BlocksCAD. So in Tinkercad, you had a drag and drop interface, which is ideal for tinkering because you're playing around, you have a work plane, and you can combine geometries and make holes in the geometries and so on and so forth. It is easier to start. It has a rich library of user-generated geometry, so you can borrow those and you can, modify your geometries accordingly. Of course, it is very difficult to make precise designs with Tinkercad. Hence, we want you to work with BlocksCAD and enjoy working with BlocksCAD.
And once you get into BlocksCAD, you're going to find that it's really easy to make precise designs in them. And also because it incorporates a lot of the coding principles and you can use variables, it can automatically resize things for you rather than using those little handles that you had in Tinkercad and moving the mouse a minute amount to try to get that dimension just right. You can also use loops like you would do in coding, and you can easily make repetitive features like maybe holes that are evenly spaced apart or things like that.
We love the fact that you will be using problem-solving computational thinking as you are creating these geometries in BlocksCAD. It definitely requires more planning, hence the computational thinking aspect of it gets emphasized. And also it has a limited base of geometry, so you're not borrowing on user-created designs, you are really creating them, hence you are a designer and maker of objects as well.
So we're going to jump right into BlocksCAD. The address is blockscad3d.com. You know what, let me switch my screen to Rashmi's screen. And Rashmi will take you through some of the basic features of BlocksCAD and beyond.
So let me share an application window. Okay. So let's go into, we should go into presenter view. Okay. So to play with BlocksCAD, you will be going to the blockscad3d.com. That's the place where you'll be working on the BlocksCAD, which kind of looks like this. As we look at BlocksCAD, and I'm going to switch between the two just to show you a comparison. This is a window that you will be rendering your objects in, and hence the discussion of X, Y, and Z coordinates. It's very important to sort of get a handle on your X, Y, Z coordinates. And BlocksCAD makes it easy for you because they have color-coded them. You have X, which is a red, Y has green color, and Z has grayish black color. So as you can see in here, you have very, just a second. You can see the colors in here. You have the green, which is your Y, X, and hence the Z. So the other thing in terms of rotation of objects, which is helpful to know before we go and play into BlocksCAD, is the right-hand rule. So think of your thumb pointing towards the direction of the axis. So if you have your Z-axis, your thumb is pointing upwards, and the direction in which your hand curls or your fingers curl, that is the rotation around that axis. So in case of Z, you are rotating as shown in the image. You're rotating this way. In terms of X-axis, when you're pointing towards your X-axis, you're rotating in the downward direction, and same goes with the Y-axis. Hence, moving on. So we are going into BlocksCAD, and these are some of the transforms that we'll be working with. So getting a quick review of how the interface works. Right when you log into BlocksCAD, you will see this interface, and then you will rename your project. Let's see, this is our trial or example file, let's see. And that will be your project name. It is very important, of course, to rename your file so that you can go back to it and edit it, and this is where you save your file. This is the project tab where you can see all the projects, and in this case, of course, it will prompt you to save, but in this case, you can see all the projects that you're working on. If you want to make a new file, you can go into the new file, save the existing file, save a copy of the existing file, so on and so forth. So let's go to the example that I was in. And this is how I can click to edit this project, and I'm back into the interface. On the left-hand side, let's go to the project menu again, and we'll talk a little bit about how you can save blocks from BlocksCAD onto your computer. This is how you'll be giving us your files. So we'll talk about that at the end of the webinar. There are also other options in which you can import an STL file, and you can save the OpenSCAD code, which we will talk about a little bit later in the second webinar. The second option is the options toolbar. So in this case, if you look at the toolbar and I choose a simple toolbox, it'll give me sort of a shorter, smaller toolbox, which you can use if you have younger kids that you're working with and you don't want to inundate them with a lot of information. So this really helps. Or you can always go back to the advanced toolbox, which gives you pretty much all there is for you to navigate. Then you have the block color scheme as well, which helps you to choose between classics and pale. This is your help menu. So there's a lot of documentation in here. You can click on it, and this is where it takes you. There is a lot of text-based documentation that you can find for the block descriptions that we'll be going through. So when you have some time, it's a good reading that you can go through. There are also some tutorials that you can visit on the website. There is also a BlocksCAD YouTube video channel. So they have some BlocksCAD quick start and some examples in here which are pretty good. So you can take a look at it as well. And we'll kind of try to point out some good examples at the end of this webinar as well. So coming back to our interface, we are going to take a quick look at the left-hand side, which is our toolbar. And in this case, first is the 3D shapes. So you have a sphere, so you can drag the sphere right onto your workplace. Render is the button that you press in order to get the object. You can zoom in or zoom out. You can also, we love to work with the coordinate plane, but if it's sort of hindering your view, You can also get rid of that. It appears when you click on this button. However, some people have asked us this question, is that the sphere that appears at the bottom of this in sort of the negative Z coordinate plane, will that print? Everything that you see in the BlocksCAD window right here is the object that you'll be printing. So essentially, this is the object that will get printed. And it's not just because it's below in the Z negative zone, it will not get printed. That's not the case. So that's your 3D shapes. Let's look at the other one. That's your cube. If we render it, right now I have the cube and the sphere positioned at the same place. So you can see that my cube is not centered, and I placed it right next to the sphere. As you can see, they're starting at the same point of origin. If I center it, you may not even see the sphere because it's you will not see the cube because it's absorbed inside the sphere. And if I delete that, I render, you can see the cube. I can again make it not centered. I can move it and make it bigger so it becomes a rectangle. I can again make a bigger cube. So it's basically you are working very precise detailed properties. And you can go into the centered version. Again, it's right in there. So that's your cube.
And all of those dimensions are in millimeters, just to FYI.
Yes. So, and then we go into the cylinder. I'm going to take the cube off. And same thing goes with the cylinder. You have multiple radii in here. And if you change the dimensions, you can see that the the cylinder is varying depending on your details. I'm going to change the height. You can see it growing. This needs to be smaller. Let's see, because we'll be working with the cylinder quite a lot. If you center it again, you have the option of centering it, not centering it. And we always recommend, depending on how you've planned your object, plan that, and then you can use these 3D shapes.
So one thing I want to point out about the cylinder is there's a lock here. And by default, it's locked, and it means the both radii on the top and the bottom are the same. So if you change one of them, the other one actually changes automatically. But if you unlock this, you can make a cylinder with different radius on either side. So you can get this cone effect. And you can even bring it down to 0, and you'll really get a cone if you do that.
So let's do that. And you get a really pretty cone. And we'll try to show this to you. There is another function in here that allows you to do this, but this is a really great option. Again, I'm going to get you to the 3D shapes. So let me, and the last one of your 3D shapes is a torus. This is a really fun object that you can play with. You have multiple properties that you can vary. So let's look at the radius. I'm going to make the radius, say 5. The radius 5. I'm going to reduce the size to 2. Sorry, size, let's reduce to 8. But faces to 2. And you can see that you're getting different types of objects. And it's a really great way of talking about the properties of the shapes, how you can vary them, what intended result would be if you vary the properties, and then actually viewing what the result is. And it's a pretty cool object to play around with. So those are the 3D objects. We quickly wanted to show you, let's bring the torus back. Okay, I think let's say, we just quickly wanted to give you an overview of this workspace. So we talked about render. Render is whatever design you have in your BlocksCAD project. That's what is rendered in as a 3D model right here. You can generate STL, which is the STL file which we send to the printer. So that's the button you will press to generate that. Of course, you have the zoom in, zoom out buttons. And of course, we talked about this, which will be toggling axis for display. Haruna, did I miss anything?
And the camera icon there actually lets you export an image file of the rendered object. So it'll prompt you to save, like, I think it's a JPEG
Right.
of that picture.
Perfect. So that's the camera icon right here. And let's get that. So once we've looked at that, let's look at the transforms. So we'll have translate, which moves objects in the X, Y, and or Z direction. So let's look at our BlocksCAD. Let's get a cylinder in our BlocksCAD. And I want to make the height, say, 50. And I want to see the cylinder. So now I have, sorry, I'm just, okay. So I have a cylinder which is set. I am going to center it right now. And I have a cylinder which has a radii of 10, second radius of 10, and then height of 50. Now I want to translate it. So let's say I'm going to translate it, making it a little bit bigger. Say around x-axis. So I have 50, which is the height. So I'm going to translate it by, say, 25. And when I render it, if you see, it translated it around the x-axis by 25. Then I'm going to translate, let's say, by y-axis, render. As you can see, it's translating around the y-axis, and same goes with the z. So, and then if you can see, it's translating around the, sorry. So now we want to also try another, let's rotate. Get rid of translate right now. Let's rotate this object. I want to rotate it by, how much are we gonna, 90?
Sure.
Okay, so we rotated by 90, and you can see that there is a very clear rotation. Same goes by, see that, 90, render. Here you didn't really see a whole lot of difference, but let's say, let's do this as 145 maybe, and then this is 0. Yes, so you can see that there are some rotations happening around the y-axis, and same goes with the z if you change this value in here. So the one thing we want to point out with transforms is that you have a translate, and if you have a rotate, it is very important to keep sort of the order of operations in mind. So what you put first, it's kind of like math. You have your first translate option, then you have your rotate option. So
so when you're doing rotation and translation together, whoops, sorry about that.
Sorry.
So in BlocksCAD, everything goes inside out. So if it's first going to generate the cylinder, and then it will rotate, and then it will translate. So whether you have rotation first or translation first, that really makes a difference on where things go. So let me first, I'm just going to render this without anything. It's in the middle. Let's say I want to rotate this around the x-axis by 90 degrees. Which would make it go that way. And then let's say I want to, you're okay, Rashmi?
Sorry, I just had that.
You want to move it along the y-axis by 100. That might kind of go too far, but we'll see. So now it moved over. So it rotated around the x, and then it moved over. Now, if I do the same thing, but in the different order, so remember where that cylinder is. Well, actually, you know what? Let me just make a copy of it. So this is what I have right now. And I'm actually going to make a copy of it and then switch the order around. So now I'm going to translate first, and then rotate. And we'll see where the second cylinder pops up. It comes up in a completely different place, because in this case, it translated it, so it moved it along the green axis first, and then it rotated up when you rotate it around the X. So you need to really be careful of which order you do things. And again, it goes inside out. So think of it as like a parentheses in a math equation. So it makes the cylinder first, and then does the inside operation, and then does the next transform. So you have to keep that in mind when you use combinations of transforms.
Right. Thank you, Aruna. Sorry. So yes, so that is a really great way of also re-emphasizing, how the operations are functional in BlocksCAD, as it also relates to how they are used to seeing operations in mathematics with the BODMAS or PEMDAS. So let's look at another transform, which is, I'm going to get rid of these. Let's get a 3D shape. Height of 50 again. This time, this is a nice way of changing colors just for your visual, pleasures. But obviously, when you have a 3D printing file, this is not the color it's going to print, or it's going to take the filament color and print the object in the filament color. So as I'm rendering this cylinder, let's say we are going to look at the transform, which is the mirror. And mirror essentially flips it across a plane, and it does not create a copy of that. So it's the same object which is being flipped across the plane. So let's say we have, I'm just going to make sure we have a cylinder right here so you can see the mirror operation. And I'm going to place the mirror, let's say maybe X, Y, Z. I'm going to mirror it across YZ. Oh, it might not show.
Yeah.
Yeah. So let's try. Okay.
Oh, you know what?
Yeah, no,
Everything's
it
centered,
wouldn't.
so
Yeah,
it's
not going to show.
Everything's
Yeah.
too symmetrical, so we can't show this at the moment. There we go.
Wait, yeah. So let's say.
That should show.
Yeah, it should. Well, let's see. Well, it's sitting on top of each other. So maybe let's try.
Yeah, it's symmetric against X and Y,
Right.
so it won't do it. So actually, if you
let's
change this back to X and Y, you'll see that another copy appears below the plane.
Yeah, right.
So that's the
here.
mirrored version. The one that's below the plane is the mirrored version.
Right. So let's try. You know what? We could actually, if this is the, we could try a torus, and that could actually give you some interesting shapes. So let's try a torus with faces 2. This could be a 6, and let's see what that gives us. Okay, tiny bit bigger maybe. 8, and then let's render that. Okay, we need something popping up, so that side's right. This is good, right? It may not show us the. Let's see. Oh, it's actually on the same plane.
Yeah, that's also symmetric. So
Yes.
mirror is kind of useful if you have things that's already been moved away from the center.
Right.
So so if you try with like a cube that's not in the center, you should be able to see it a lot better.
Let's try the cube that's not centered. Yep, and then okay, go away, Taurus. We have this.
So now it's
yeah.
not centered, and if we mirror it, you should see it moving across different planes.
Command V. Let's put it in here. Yep. So you can see that it's mirrored across XY. You can see this is mirrored across the Z-axis, XZ, and then you can see that it's providing you the original and the mirrored version. So that's your mirror. Again, we emphasize if you have mirror, you have translate, it's going to follow the order of operation as you place them and as you're combining translate, rotate, or mirror operations. And we also quickly wanted to show you this plus sign, which allows you to add another object in here. So let's say I want to add a cylinder, and let's see what that renders. So I want to have the height of say 50. And you can see that now I have a sphere, I have a cube, and I'm going to take this out. So I have a cube and a cylinder that's mirroring across the YZ axis. So essentially the plus sign in any of the objects that you use or any of the functions that you use will allow you to add more functionality and or subtract more functionality depending on how you want to create your object or what your plan is. The other transforms we wanted to add or show you quickly were, let's take another. We wanted to show you the color option. So you can have multiple shapes in here, and you can add colors to that. So you have all the spectrum. And this is especially helpful if you have different objects that are getting transformed. Like in the earlier section where the mirroring, we have two objects, and we can designate different colors to those objects. You can also add sides. So let's say color blue, and then I have sides. So in this case, I have cylinder with 8 sides, so that's what it's going to give you, which is a wonderful, beautiful octagon. I can also get a pentagon in this case, just from the cylinder, and I can decide on the height, which could be 5 in this case. So I have a nice little pentagon or any sides, essentially, defining go ahead.
And the sides transform only works with cylinders and spheres. And sometimes when you have cylinders or spheres of very small dimension, like 2 millimeters, you'll notice that the automatic rendering will give you a very like boxy cylinder or sphere. So you can actually increase the number of sides and get a smoother circle if you use the size option. So it's useful for making polygons and also for just smoothing out what they initially give you.
Mm-hmm. So herein we have a sphere of radius 10, which let's just render that. And we have a sphere right here. And then in this case, because we are changing the color and then we are adding the slides transform to this, this is your nice little diamond. Or
you can try increasing that to like 100 to the size to see what you get. You'll actually get a much smoother sphere if you do something like that. So it does take longer to render, but if you're in need for something very smooth, you can do that.
Right. So this is the, again, awesome. So those are just a few other transforms. Then we also wanted to show you, I'm going to bring the cylinder back in. I have a pentagon here. Let's do, okay. And in this transform, let's bring back taper, which is a pretty interesting one to look at. It will not taper, so let me get, sorry, yep. I should get sphere in there just so that they see the, and let's see, whoa. Okay, so you can start seeing this is a sphere. That's the radius of the sphere. That's the original object. And then when I add taper and I'm axis scaling by 5, you can see that it's tapering.
So yeah, so 5 is, if you use a number bigger than 1, it makes the end bigger. Right. So that's why the one end got bigger, kind of along the x-axis. But if you make the scale smaller than 1, down to 0, then
Right.
it'll come down to a point. So you can play with that to get interesting geometries that way.
Yeah, and now you have a nice little teardrop. You can also vary it along different axes, and you have this nice little beautiful raindrop that's taking place right here. And change the color, change the object, and you can play around with it. So that's scale and taper. And now we'll talk about a couple more options. So I'm going to transfer it to Haruna.
So I'm going to take on from here. Let me just share my screen. All right. So I'm going to continue down the different options on your menu. So we went through most of the transforms. And the ones that we didn't cover, feel free to play with them. I am now going to go into set ops, which is for combining different geometries. So right now I have a sphere and a yellow cube or rectangle. And if I render it, you'll see that I have a sphere and a rectangular bar intersecting each other. Now, set ops lets you combine them using union. Difference would subtract one from the other. Intersection will take the parts that are intersected, and then hull, which is fun, so I'm going to show you in a minute. So I'll start with the union, and the way to use it is just to drag your geometries in here. Again, you can add more objects if you like to. Right now, I'm only having 2. And union is, you'll actually not really see much happening because all it's doing is combining this. But what you can do now is treat this as one object and apply transforms to this combined object as one thing. Remove that. So difference. So difference is this first object minus the second object. So in this case, it's going to take the sphere and subtract the bar from it, which you will end up with a hole going down the middle. So you can see right through it. The order of operation matters in the difference. If I change this around so that the sphere comes later, then it takes the bar and subtracts the part that used to be the sphere. So you need to keep that in mind.
And this is really helpful because in Tinkercad you've seen the whole and the object, but in this case you are really planning as to what your end object is going to be, and that goes into your plan. Hence, the order of operation matters, how you plan the object matters, and so on and so forth.
So intersection will take the part that both geometries occupy. So in this case, you will get this portion, which was taken up both by the bar and the sphere. And the final option, the hull, is it basically, think of it as like stretching a rubber sheet over your entire geometry. It kind of covers everything with this, with a skin almost, and makes a nice smooth three-dimensional solid around both of your objects. So again, what we had originally was this. And after you hull things together, you get something like that. And to use the hull, you don't have to have intersecting geometries. So I could have 2 different objects that are completely in different places. Let me just move the sphere over by, let's say, 50 to show you that. So now I have a bar and a sphere totally in different places. And I can still combine them together using this option and get very interesting geometries happening. Okay, so I'm going to go into one of the projects that you will be doing for your homework, which is to make a box that's resizable. And we'll take you through step by step. But before I do that, let me just show you what I mean by that. So this is the box. And we are going to be using something called variables. And the importance of variables is rather than just typing in your dimensions right into your blocks, you set up variables so that you can use the variables to easily resize objects. So in this case, for the box, I'm going to have a length, which I just covered up, length on the bottom, width and height, and the wall thickness. That would be my important dimensions. So in BlocksCAD, just get a clean slate, hang on. What I'm going to do is have a cube, start out with the cube, and I'm going to center it since it's a little easier for me to think about it. And to make a box, you would need to subtract a smaller box from inside of here. But before that, I'm gonna go into the variables. So there is a tab for variables. There are only two things in there. One is to set item 2. This is for you to create a new variable. And you can rename it. So I'm gonna go ahead and rename this as L. That's for my length. And then you need to assign a number to this variable. And to do that, I'm going to go into the Math tab and drag out a number. And I'm going to say my length of my box is going to be 50. Now I'm going to drag another variable. Now I'm going to rename this as W for width and do the same thing. Now I want my width to be, let's say, something a little smaller. I just did a right click and a duplicate so that it's a little bit faster. So I have a height. Once again, right click, duplicate, copies the block, and I will call it thickness. And we want the wall thickness to be something small, so I'll just say 2. So the outside of this box needs to be, the X will be L, Y is going to be W, and the Z is going to be the height. So we can go into the variable and actually drag out these new blocks that came about. These blocks were generated when you made your variables. You can also do that by right-clicking on your original variable block and say get L, create get L. That makes the same thing, so you can do that too. So this now makes my blocks. That's the outside of the box. And if I change my variable, then my box changes accordingly. And I haven't done the hole yet. So my hole is going to be the same thing. It's going to be a cube. But what I need to do is the length, going back to my slide, the length needs to be L minus twice the wall thickness. And I'm saying twice the wall thickness because we have the wall on both sides of the box. So to do that, we are going to go into the math block. And the math block, you really only see this one block here for calculating things. You can change the operator in here, the plus, minus, multiply, divide, and the exponent to do any math operation you want. So what I want to do is L minus, and I'm going to drag another one of these in here, wall thickness times 2. Okay, so that is going to be my new X. And now you can see that this cube block is getting rather long. And it's kind of running into my render window. So I'm going to say, right-click on it and say external inputs. It sounds a little strange, but that just changes the layout of the block so that you can attach variables, the attributes vertically. So now I'm going to duplicate this and do the same thing for the width of the box. Width is going to be W minus 2 times the thickness. And the Z is just going to be height. Okay, so if I render this, and I'm going to put a different color on this so that we can see a little bit better. So this hole will be yellow. Everything looks good except I don't have a base down here because my height is still the same. So what I'm going to do now is move this over. I'm going to translate this by the same amount as the wall thickness. So now the yellow block you're going to see will come up a little bit, and then the base will be solid pink. So if I take this now and do the difference operation on these two things, now we get a box, okay, with actual bottom. And the great thing about this and using variables is now I can, let's say I just wanted to say, okay, I want the thickness to be 1 millimeter now. I want a thinner shell. All I had to do was change this one number right here, and everything changed along my program so that I don't have to go in here and change every single one of these numbers. And you know, it eliminates mistakes. If you're resizing something and you have to go in and change 10 different numbers, there's a good chance that you might miss one of them, and then it's also very time consuming. But setting up the variables like this eliminates all of that. And you can very easily change how your box looks and not have to worry about, you know, making any mistakes. Once you have this program for the box set, all you need to do is change the dimensions and it'll automatically make the box for you. Oh, I do want to show you a few more things. So just as a debugging tool, there is a way to disable blocks temporarily. So let's say I'm doing this and something is wrong and I really don't want to do this whole right now because until I have something, I have it figured out. You can right click on it and say disable block. That shade gives it a gray shade and it temporarily disables that block and it would not render that block. So now I have my original block, not the whole. And if you know, once you're happy with that, you can bring it back by saying enable block and render it, and you don't have to worry about that. So it's a really good tool to debug things when something is not going right, or maybe even if you have, you know, that part is all set, you don't want to see it for now. Before, when you're designing a different part of it, you can temporarily disable things. You can also collapse blocks. So you can see how easily this will, you know, how quickly it'll become rather large and take up your whole screen. So now that I know this part is all set, I can say collapse block, and it becomes one little line. All the blocks are still there, but you don't see it. You can also always expand it back. You can also insert comments on it by saying add comment. It opens up this little question mark. So I can call this the whole. And the nice thing about doing that is when I collapse it now, it shows me the comment so that I know exactly what this little bar was. So this is really recommended for you to clean up your work area if your program is getting a little too big. It's a really nice way to just improve the visibility of your workspace. And then I think, text. I don't think we went into text. So text is a nice option also to, and actually as part of your assignment, we're going to have you personalize your box. And when you click on text, there is a 2D text and a 3D text. And for now, we're only going to use the 3D text. And the gray box here is what you're actually typing up. Size is the height of the text. And then the thickness, so let me just render this and show you what I mean. So thickness is how thick these letters are. You can select several different fonts. There are not too many. And you can center it or not center it, like before. And the text always shows up pointing up in the Z direction. So if you want to put your text on the side of this box, then you're going to have to play around a little bit with the rotation and the translation. So just to show you, for example, if you rotate around the X, which is the red axis, so imagine you twist this red axis, then you can make the text stand up. And then you can translate it along the Y dimension to get it on the side of the box. Now, when you do this, you can just type in the number. Let's say I want to move it by 15. Or you know that your box is so many millimeters wide because you have your width. And you can work from that number. You can say, I want to move it over by the width divided by 2, for example. Then it will, you know that it will move over by the correct amount. Actually, I want to move it in the negative y direction, so I'm going to say width divided by -2. If I do that, it's going to move exactly the right amount, and even if you change the width, it still appears in the right place. So if you had sort of just played around with this number and typed it in, manually, then even if it appears right for that moment, oops, that should have been a -20. As soon as you change your width, text gets left behind. But if you used variables, that's the real strength of the variables, is no matter what you do, your text is still in the right place. All right. So I think we went through a lot of these blocks. There are a few more to cover, but we'll save that till next week. But we do want to give you some tips for using BlocksCAD. Number one is to plan ahead. And just like we did in Tinkercad last week, you want to sketch and write down the key variables and key dimensions, and really think about which dimensions need to be a variable and which dimensions depend on some other variable, and think about that and start getting your thoughts together before you start programming.
Right. Render often, which is also very essential as you're changing dimensions and changing values of your variables. It really gives you a good visual when you are rendering your objects. And also try to apply transformation one at a time so that you can actually see the differences as you render them.
And that's really important, especially if you're combining things like rotate and translate. If you do two things at the same time, and it doesn't end up where you expect it to end up, it's really hard to debug and see where it went wrong. And along the same line, you want to change one thing at a time when you're changing things. If you change, if you are translating and rotating and change both numbers at the same time, it'll get really difficult to debug.
Yes. So use disable enable blocks. That is a really great feature. It helps you debug. It helps you troubleshoot. It also helps you as you're rendering objects to go back and see how your object initially was, what you wanted to plan. So it helps in terms of defining how you would want to proceed.
And also the comment and the collapse block, they're very nicely used in combination so that when you collapse it, you know which blocks they are. But that will save you some space on your workplace and make it easier for you to do stuff.
Right, and going back to, again, cleaning up your workspace and making it more logical as you are rendering your objects, use color. It helps you distinguish different parts. As Haruna used the pink and the yellow, you can see the whole has a very specific color, and that's a really good way of looking at your objects.
And when you're using the operations like difference and intersection and hull, you want to make sure that all parts are in the right place before you apply the operation. So for example, when I did the rectangular hole through the sphere, if I applied that difference operation before I saw that the stick was in the right place, and if it wasn't in the right place, it's actually really hard to see what's wrong. And sometimes, the geometries wouldn't even be intersecting if they're in the wrong places. And if you apply the operation and nothing happens, it's hard to see a hole when you don't actually see the shape of the object there. So you really want to make sure they're in the right place before you combine them into the difference, intersection, and hull. A couple more resources. The YouTube channel, we're going to leave the link here, and you can see it from the slide deck. Rashmi showed you the YouTube channel already, but this is just a link. And same thing with the BlocksCAD, the help menu. The link is right there.
Perfect. Yeah, so our session 2 assignment.
Oh, session 4. I keep on missing the slide.
No, it's session 4, assignment number 2, is, of course, the first one is what Haruna showed you. You can design a personalized box or a cup for your desk. That could be a business card holder or whatever you would like to design it for. We do want to see text on it. And
text or some decoration.
Right. That's a good way. And option 2 is you can design a 6-sided or more sided die with numbers, letters, symbols of your choice. We'll show you a couple of examples of how to do that. But the requirements for this assignment are?
Yeah, so again, we want to see evidence of planning, so some sort of a sketch or some form. And we would like you to use at least 2 three-dimensional shapes. So that's sphere, cube, cylinder, torus, or text. We want to see at least 2 of those. And we would like you to use variables so that the design is resizable. Let me just show you the die, the option 2. Should we?
Yeah, let's go to the...
Just show you on, well, I'm going to first show you the real thing on camera. So this is a 6-sided die, but that goes from 0 to 5. And then amazingly, on the same day, without even planning, Rashmi was making this other cube that has operations on it. Yep. So if you combine something like this with a tool like that, and you can play a lot of different math games. You can roll the dice and you know, combine the numbers as you see. Right. So this is what we were talking about. And actually, if you notice, both of these cubes are rounded, but they're rounded in a different way.
Different ways, yes.
So you're gonna go through, okay. So Rashmi will go through this portion. This one is actually an intersection of a cylinder. I mean, a sphere and a cube. So it cuts off the corners. So we'll switch back to Rashmi's screen, and then. All right.
Okay. So in this case, there are a couple of ways in which you can do this. So the first example is, and I was playing with it a little bit. So let's render this. And you can see the code in here. And you can see that I have a cube in here. And you can do this with variables right now. I have number of values in here. But I have a cube, and then you have 8 spheres situated at the ends of that cube. So you can plan it, design it accordingly. Obviously, we have used translate in this to place the cubes, place the spheres at the corners of the cube, and then I'm going to use the wonderful setups, which is the hull, and I'm going to place this inside the hull. I'm going to render it, and that's going to give you the cube that we showed. Of course, you'll have to start putting either 1, 2, 3, 4 of the text or whatever operation plus minus that you would want on the sides of this die. And again, you'll have to use the rotate or translate depending on where and how you want to place the object.
And this is a really good example of why you would want to use a variable, because you know, let's say you wanted to change the size of this cube, and you really don't want to go into that code and change every single one of those numbers. Where if you had one variable that said length, that's, you know, you only have to change that one number and everything will change for you.
Right. So again, what we want to see is an evidence of how you are essentially making this code efficient. So we've shared an example of one without the variables, especially so that you can take this code, you can modify it, but then think about how you can make it more, how do we say it, efficient and transferable to different sizes. The other way you can build this is by using just spheres as your points of reference. So let's take a look at, do we have that example, Aruna? Where what we have is 8 spheres placed instead of the cube, which is the.
I don't have it open, and it's in my other account, so I'd rather not show it. But it's basically the same thing, but without the cube in the middle. Right. And because you're hulling it, you really don't need the cube in the middle unless you need it to help you with the visualization.
Right. So either way, what we want to see again is an evidence of you using variables with this example, or the first example, which is designing the personalized box.
And to submit it, you're going to have to go to, in BlocksCAD, go to Projects and save your blocks to your computer. So you're going to go to Projects, save your blocks to your computer, and that will generate something called an XML file, which then you can send to us as the assignment.
To submit, of course, you can always go to our course website, which is a tiny.cc BPS 3D printing, and go to the resources tab. click on session for assignments form and attach your XML file to that and submit, and we'll receive it. We want you to send us the XML file so that we can see how you are planning and implementing your project in BlocksCAD. If you send us an STL file, then we don't really get an opportunity to see the blocks and how you've designed your object.
But yeah, that's a good point. The STL file, which you'll get here, is for 3D printing, and you'll get the 3D file. So if you are planning on printing, you don't print with the XML file from here. You do it from this STL file down here. So just keep that in mind. And that's it for this session. I know it was a long one. Next session, we'll get into more details about BlocksCAD and get into things like loops and functions. So thank you for watching.
Thank you again. See you soon.
Oops, I lost my screen.